Hello everyone. Today I'd like to introduce you to the bidirectional programmable DC power supply photovoltaic cell matrix simulation software. The software with NS91000 series can accurately simulate the IV and PV curves of solar cell matrices with the characteristics of accurate measurement, high stability, and fast response speed, which is used to test the static and dynamic MPPT of photovoltaic inverters, and it can provide support for the system simulation of microgrids, distributed photovoltaic and other power systems, as well as for the testing of core equipment. Running the software, users should click Communication Configuration firstly, fill in the IP of the device, port number 7000, ID number 1, and click Communication Test. Normal means users can begin to connect. Click Connect and enter the main interface. There are 3 areas included: Analog Display Area, Control Area, Information Area. The software supports multiple modes: Static Sandia, Static EN50530, Dynamic Sandia, Dynamic EN50530, Weather Test, Shadow Test 6 standard modes, and our custom modes: Customized Curve Sequence, Curve Parameter, display the final open circuit voltage, short circuit current, max power point voltage, max power point current, max power point power of this curve, measure value, display the real-time operating voltage, current, power, instantaneous MPPT, accumulated MPPT, energy, test duration of the PV simulation panel. Firstly, connect the inverter to the N35500 and check the model of the inverter to determine its maximum operating voltage, current, and power. Note: the open circuit voltage should be slightly greater than the maximum power point voltage, and the short circuit current should be slightly greater than the maximum power point current. The above settings must not exceed the maximum operating voltage, current, and power of the inverter. Set the initial time to 60 seconds. Mainly depends on the inverter. The general initial time is 50 seconds, approximately 90 seconds. Set the on time to 70 seconds, higher than the initial time. And finally click Initialize. Voltage protection will pop up at this time. According to the Static Sandia rule, VOC, ISC, Vmp, Imp, Pmp will be calculated. Fill in the maximum output voltage of the inverter. If the maximum output voltage is lower than the actual open circuit voltage, it will not be able to start. Click Verify, then Start Test. At which point the inverter starts working to find the maximum power point for simulated PV panel. Static Sandia Advanced. Users only need to configure PMP, Vmp, initial time, on time. Other parameters do not be set. Click Initialize. Confirm that the VOC will not exceed the maximum voltage of the inverter. Then start test. The Static EN50530 Basic operates in a similar way to the Static Sandia Basic. The Static EN50530 Advanced operates in a similar way to the Static Sandia Advanced. No more demonstrations here. Click Dynamic Sandia. First set the parameters. Only need to set the PMP, Vmp, initial time, and then select Change. There are Slow Change, Fast Change, Triangular Shift 3 ways to simulate the maximum power characteristic curve under different irradiance. After setting, click Initialize and start testing. Users can see the IV, PV curve changes under different irradiance. Click Dynamic EN50530. First set the parameters. Only need to set the PMP, Vmp, initial time, and then select Change. Irradiance from 100 to 500. Cycles from 2 to 10. Slope form 0.5 to 50. Ramp up 8 seconds to 800 seconds. Ramp up 8 seconds to 800 seconds. Any one or more groups of parameters can be checked for testing. Due to time constraints, we chose the fastest set of parameters for testing.
Click weather test. Set PMP, Vmp. Initial time to 60 seconds. Interval time to 60 seconds. Users can also set a weather curve. You can click Select File to import the compiled weather curve, or directly select the typical weather, such as cloudy, sunny, overcast, cold day, hot day. Then click Initialize to start test. The maximum power characteristic curve can be simulated under different irradiance and temperature. Click Shadow Test. The rows and columns of the PV panel can be set. For example, set 9 rows and 11 columns. Left-click to select the shadow area and direction of movement. Select the shadow area and direction of movement. Note, the PMP and Vmp is the parameters of a single PV panel. Click Initialize and then Start Test. The curve in the upper right corner is the parameter of the whole PV panel. Click Customize Curve. First click Curve Editor. The software built in 17 curves. Users can view the IV, PV curve by selecting them. Curve 1 to Curve 15 are composed of 256 points. Curve 16 to Curve 17 are composed of 2048 points. The more points the curve has, the more real it is. Users can reconfigure the curves according to their own inverter parameters. For example, if we want to modify Curve 17, we can first export the curve to CSV format, then edit the specific value, save the file, and then re-import the file. Click Curves Writing Device to write these 17 curves to the device. Click Curve Number again. Select a curve to execute. For example, if we choose 17, set the initial time to 60 seconds, on time to 30 seconds. Click Initialize. At this time, a voltage protection will pop up. According to the Curve 17, actual VOC, ISC, Vmp, Imp, Pmp of the PV panel will be calculated. Fill in the maximum operating voltage of the inverter. If the maximum operating voltage is lower than the actual VOC, the device cannot start. Confirm and click Start Test. The device operates according to Curve 17. Click Curve Sequence. There are Sequence 1 to Sequence 10. For example, under Sequence 1, the maximum steps can be set to 10, where step actually means how many curves are to be used. If we set 3 steps, then Step 1, Step 2, and Step 3 will be lit. Set Step 1 to Curve 17 for 40 seconds. Step 2 to Curve 4 for 30 seconds. And Step 3 to Curve 6 for 35 seconds. Click Initialize. Enter the maximum voltage of the inverter. Confirm and Start Test. And it will be running in accordance with the Curve 17, Curve 4 and Curve 6 in sequence. The tested data can be queried in the history data.
Double-click on any data column to open the data table. Click Export Data. Data file can be generated in Excel format.